Hey guys, welcome back to my YouTube channel, and in today's math help video we are going to go over long division and graphing polynomial equations in factored form. Let's first start off with long division. So to solve long division, there are 4 steps you need to follow. So first you're going to divide and then multiply, then subtract, and then lastly you are going to repeat those steps. So let's first start off with this example here. So first we are going to rewrite the question. So it's going to look like this instead. X minus 2 divided by x cubed plus 9x squared minus 5x plus 3. Okay, so now using the first term in the binomial, how many times can x go into x cubed? It can go in x squared. So to find that out, you divide, and then now we're going to multiply x squared by x, and you get x cubed. Then multiply x squared by negative 2, and you get negative 2x squared. So next is subtraction. So that is 0. Then 9x squared minus negative 2x squared gives us 11x squared. And now we bring down the next term, and then we repeat. So how many times can x go into 11x squared? So with division, you get positive 11x. Now you multiply. So 11x squared, 11x times negative 2 gives you negative 22x. Then subtraction, that's 0. Negative 5x minus negative 22x gives us 17x. And then you're going to bring down the last term. And then how many times can x go into 17x? Can go in positive 17 times. Now you multiply. Then 17 times negative 2 gives us negative 34. Then you subtract plus time, so that's 0. 3 minus negative 34 gives us 37 remaining. So that's all you have to do by following these steps to solve a question like this. So now let's move on to another example. So in this example, if you notice, we are missing an x value. It goes from x cubed to x squared, but then we're missing a single x term. So if you ever come across this, you always have to add a 0x. So the new question would look like this: x cubed minus 2x squared, and then we are going to add a 0x, then minus 4 divided by x minus 3. And now we're going to rewrite the question exactly like we did the last one. We're going to use the same steps from last time. So using this term, how many times can x go into x cubed? X squared, then multiply. That gives you negative 3x squared. And now we're going to subtract. That's 0. Negative 2 minus negative 3. That gives us positive 1. And now we're going to bring down the next term. How many times can x go into x squared? Just x. And then multiply. Multiply. And then subtract. That's 0. 0 minus negative 3x gives us positive 3x, and then bring down the last term. How many times can x go into 3x? Can go in positive 3. Then you multiply. 3 times negative 3 is negative 9, and then you subtract, and you get 5 remaining. Okay, so this is the last example we are going to go through today. So this one is slightly different because it has a coefficient on the x. So we're going to follow the exact same steps. So we're going to first rewrite the question. Okay, so using division, you can find out how many times 3x can go into 6x cubed, which would be 2x squared amount of times. And then you're going to multiply and you get 6x cubed. Now 2x squared times by 7 gives you positive 14x squared. And now you subtract, that's 0. Then that is 6x squared. So now you're going to bring down the next term. And how many times can 3x go into 6x squared? It can go in positive 2x times. Now you multiply. Then 2x times by 7 gives you positive 14x. And now you subtract. And that's 0. And then 5 minus 14 gives you negative 9x. Now you're going to bring down the last term. How many times can 3x go into negative 9x? It can go in negative 3 amount of times. And then negative 3 times by 3x gives you 9x. And then negative 3 times by 7 gives you negative 21. And now you're going to subtract. So that is 0. Negative 21 minus negative 21 gives you 0 remaining. Okay, so now let's move on to graphing polynomial equations in factored form. Okay, so let's first go over what factored form is. This is what factored form looks like. And basically, factored form is very useful for graphing because it gives you the zeros or the x-intercepts of your graph. So to find the x-intercepts when your equation looks like this, all you have to do is set each binomial to 0. So for the first one, x plus 1 equals 0, and then you get x equals negative 1. For this one, x plus 2 equals 0, x equals negative 2, and for this one, x minus 1 equals 0, x equals positive 1. So negative 1, negative 2, and 1 would be the x-intercepts of this equation if you were to graph it. Okay, so there's a few more things you need to find before you are able to graph a polynomial like this one. So we already found the x-intercepts, and now you need to find the degree, the leading coefficient, the m behavior, and then the y-intercept. So first, to find the degree, you're going to multiply all the factors of x together. So in this equation here, we're going to multiply x and then add the squared. So x squared times by x times by another x gives us x4. So therefore, the degree of this function here is going to be 4. So the degree is going to always be the exponent on x when all the factors are multiplied together. So now to find the leading coefficient, what you have to do is multiply all the x coefficients together. So in this equation here, all the coefficients on x are 1. So we're going to multiply 1 times 1 times 1, which gives us 1. So the leading coefficient for this function is 1. So now to find the end behavior, all we have to do is use the degree and the sign on the leading coefficient to determine what the end behavior is. So the leading coefficient is positive and the degree is even. So therefore, it's going to go from quadrant 2 to quadrant 1. So now lastly, all we have to find is the y-intercept. Okay, so to find this, we're going to set all the x values to 0. So f at 0 equals 0 plus 1 squared, 0 plus 2, 0 minus 1. Then y equals 1 squared times 2 times negative 1. So that gives us -2. So before we are able to graph a function like this, you probably noticed this exponent on this binomial. So that is an order of 2. So there are 3 orders you need to know, which are order 1, 2, and 3, and I'll go over what each one means before we graph a function like this. So if it has an order of 1, when you graph the function, it's gonna go straight through the x-axis. And then for an order 1, it's going to have an exponent of 1. And then for an order 2, it is going to bounce off the x-axis. And this one would have an exponent of 2. And then for an order of 3, it's going to create an S shape going through the x-axis. So I'll show you what each one of these would look like in a graph. So I'm gonna plot just some random x-intercepts. So the first one, if it's an order of 1, it would just go straight through the x-axis like that. And then if it's an order of 2, it would bounce off of the x-axis. So it would hit the x-intercept and come straight back down. And then if it's an order of 3, it's going to create a little curve as it's going through. So now that we know what each order means, how to find the degree, the leading coefficient, the end behavior, and both x and y intercepts, we can now go through some examples and start graphing some polynomial equations. So the first example we're going to start off with is going to be this one here. Okay, so first we're going to find the degree. So we have an x squared and an x. So we get x cubed. So the degree is 3. And now the leading coefficient, we have a -2, and then a 1, and a 1. So in this case, the leading coefficient is going to be -2. And now we're going to find the end behavior. Since the leading coefficient is negative and the degree is odd, the end behavior is going to go from quad 2 to quad 4. So now let's find the x-intercepts. So we have x minus 1 equals 0, which x equals 1. And then x plus 2 equals 0, and then x equals -2. So our x-intercepts are 1 and -2. And now lastly, our y-intercepts. So we're going to set x to 0. And y equals -2 times -1 squared times 2. And then this equals -4. So our y-intercept is -4. So now we are going to graph. Okay, so first we're going to plot our x and y intercepts. So we have one at -2 and we have one at 1. And then our x-intercept is at -4, which would be around there. Okay, so it's going to start in this quadrant here, quadrant number 2, and end in quadrant number 4. So now we're going to look at our orders. So the first x-intercept is -2, and that has an order of 1. So that's going to go straight through the x-axis, and it's going to go through the y-intercept, and then before we reach the next x-intercept, it has an order of 2, so it's going to bounce off the x-axis and come back down. So that's basically what the graph of this function will look like. So now let's try this one here. So first is the degree. So we have x cubed and x. So the degree is going to be 4 for this one. And now the leading coefficient. So we have a -1, 2, and a 1. So the leading coefficient for this one is going to be -2. And now the end behavior. So since the leading coefficient is negative and the degree is even, the end behavior is going to be quadrant 3 to quadrant 4. So now the x-intercept. So first we have a 2x plus 1 equals 0, 2x equals -1, x equals -1/2, and then we have an x minus 3 equals 0, x equals 3. So those are the two x-intercepts for this one. And now we're going to do the y-intercept. So f at 0 equals -2 times 0 plus 1 cubed, 0 minus 3. So then y equals -1 cubed times by -3. So our y-intercept is going to be 3. So now we are going to graph. So first we're going to do the same thing as the last one and graph the x and y-intercepts. So we have one at -1/2, then one at 3, and then our y-intercept at 3 as well. So our first one has an order of 3, and it's going to start in quadrant number 3. So this one's going to go through and make an S shape. It's going to go through the y-intercept, and then it's going to come straight through that x-intercept. So this is what this graph would look like. So now that we've gone through multiple examples of both long division and graphing polynomial equations in factor form, I think you're ready to go on your own and start doing some practice.